Okay, well, I've got 7 o'clock, so we will get started. So today I am covering adding and subtracting polynomials. I do have a video in the classroom on what a polynomial is, and it goes in depth into polynomials. I'm just going to briefly talk about the definition of a polynomial. And if you still need more information, you can go and review that one. So this is the math definition of a polynomial. So we have these values a0, a1, and so on until an. The a0 we actually say out loud is a naught. And the numbers are just subscripts acting as labels, and a just stands for a number. So these are just numbers, basically just in a row. We're just kind of listing numbers. And we have some number of them. A polynomial is an expression where you have a number times a variable to some exponent, and then you have a bunch of those added together. So we usually have the highest exponent first, and then they kind of count down from there. So we're looking at things that are not just x, but maybe x squareds, things with higher exponents. And you just have these added together, and that's what makes a polynomial. So everything that's separated by a plus is called a term. The numbers in front of the variables are called coefficients. The exponent is called the degree. And then the highest exponent term, which goes first, is called the leading term. The number is called the leading coefficient. And then the one that doesn't have a number is called the constant. So that's just briefly what a polynomial is. So to add and subtract polynomials, you need to understand like terms for these things. So specifically, things are like terms if they have the same variables and the exponents on those variables match. So this is actually from the textbook, giving some examples of like terms and unlike terms when you have things that are polynomials. So if they're both x squared, they have the same variable and the same exponent, so those are like terms. And you could have combinations of letters, so like a yz cubed, they both have y, they both have z, and the exponents match, those are like terms. But unlike terms, which you cannot combine, would be if they have different exponents, like they both have z, but one's 2, one's 6. Or if they have the same exponent but the letters are different, those are not like terms. Or if one has a variable and one doesn't, you can't combine those either. So we really have to look at like terms and what are considered like terms in order to add polynomials. So basically, adding and subtracting polynomials is simply combining like terms. So sometimes you need to do some multiplication first because you have to distribute, and then you do addition and subtraction. So you're basically following the order of operations. So if there's any multiplication to be done, you do that first, and then you do your addition and subtraction. Now, my general tip, and I'm going to be doing this in this lesson, is if you are subtracting, instead of subtracting, you write it as adding a negative and then distribute the negative. And I do it this way because a lot of people, when they're adding and subtracting polynomials, tend to mess up the signs, especially when they're subtracting. So if you do it this way, you're less likely to make a mistake and get the wrong sign. So that's why we're going to do it that way. And this is something I've said pretty much all term, is, if you mess up signs, write it as adding a negative because that will help you. And then the last thing that a lot of people tend to do is when they get to polynomials, they want to add exponents together because you're also at the same time learning about the exponent rules. But when we're adding, we do not combine exponents. Everything stays the same. It's when you're multiplying the exponents add. So we're not changing any exponents with what we're doing here. So we're just going to go through several examples so that you have an idea of, what you're doing and how this works. So I'm going to just start with the top left, and the directions say simplify. Simplify is basically telling you add or subtract, do the order of operations, try to combine these, make these as simple as possible. So even though it doesn't specifically say add or subtract the polynomial, that's what you're doing. You're basically trying to combine these. So we have negative 5ab cubed plus 17ab cubed. These are like terms because they both have a with no exponent, and they both have b with an exponent of 3. So these are like terms. So I'm going to show all of the work that we do, and then most of the time we don't actually write all of these steps, but I'm going to show it just so you can see what's really going on. So generally what we do is that we kind of pull out our ab cubed because that's what's in common, and then we kind of look at what's left over. And this is actually the distributive property right here, but we're doing it in backwards. So if you go back to week 2 when we were learning all the rules and we learned the distributive property, this is one of the things that you can do is you'll have something times things in parentheses. And so what we do is we just add. So we have negative 5 plus 17, which gives us 12. So we're just combining those. And then we normally like to put the number first. So we would rewrite this as 12ab cubed, and that is the commutative property. And that was also in week 2. We were learning all the different properties, and that's where you can change the order of multiplication. So when we're doing this simplifying process, we're basically, you're combining, you're adding the numbers, and then the variable parts just kind of hang out. That's what we're doing. So we don't normally show all of these steps. We'll usually just do this in one step with the final answer. But these are the rules that allow us to do what we're doing. So if we go to the example on the right, we've got 23x squared y plus 12x squared y. So they both have x squared, they both have y, so these are like terms. So you just add 23 plus 12, and that gives you 35. So our answer is 35x squared y. So you don't do anything with the variables, they just hang out. You're just adding the numbers. Are there any questions on those two? All right. Now, the ones underneath this, these are going to require a little bit more work because you can see that they're longer. They've got more things going on. And these are truly polynomials that we're adding together. So what we have are two polynomials, and the polynomials are put in parentheses so we can see with them grouping together, that we're adding these two polynomials together. The parentheses themselves are completely unnecessary because we do not have numbers in front of the parentheses, and we don't have like a minus in front of the parentheses. So we don't need these at all. They're only there to show you that there are two polynomials. But this is no different than if I wrote it without the parentheses and just completely ignored them and had something like this that you were simplifying. So they're only there for show. They're not actually necessary. So when you're doing a problem like this, you need to figure out what your like terms are so you can combine them together. So color coding could be helpful. So we have a negative 3w squared, and that matches with a 5w squared. So those are like terms. So sometimes it's helpful to rearrange this and put those next to each other. and that is the associative property and the commutative property that allows you to rearrange things and then kind of group things together that match. And then we've got a plus 4w, and there's nothing else with a w, so I don't really have anything to match that up with. And then we've got a minus 6 and a plus 2, so I can kind of rearrange those and put those together. So all I'm doing is rearranging things so that the stuff that's together is together. So that way you know what you're adding, and you can combine your like terms. So if we go left to right, I've got a negative 3w squared plus 5w squared. So you do negative 3 plus 5, just 2, and that gives us 2w squared. Then I have my plus 4w, and there's nothing else to add that to. And then I've got my minus 6 plus 2, so when you do a negative 6 plus 2, that gives you minus 4. And this is our final answer. So in this case, and this happens a lot when you are combining and polynomials, when you're adding and subtracting them, you're not going to get one number or one term as your answer. Your answer is going to have multiple pieces, but it has fewer pieces than we started with, and that's the goal. So you just keep going until you don't have anything else that you can combine. And we can't combine these because they're not like terms. So are there any questions on that problem? Okay, so the next one on the right is another one where we've got two polynomials that are separated with a plus, but we don't really need the parentheses. So I'm going to just rewrite it without the parentheses. And if you want, instead of writing that minus 4t, you can write that as plus a negative 4t. Now, the order that we do our addition and everything really doesn't matter, but we try to start with the highest exponent first. So our highest exponent would be this t to the fourth and the 3t to the fourth. Those match. They both have an exponent of 4. They both have t. So that's sort of what we want to start with. So I'm just going to rearrange this. So I have t to the fourth plus 3t to the fourth. And then our next highest exponent is the t squared. So that's right here. And then we don't have anything else with the t squared. So I'm just going to write plus t squared. Then the next thing is we would want to have the t. So if you don't have any more things with exponents, you go to the variables. So we have things with t. So I have a negative 4t and a 2t. So we're going to group those together. Negative 4t plus 2t. And then the last thing that we have is the 6. And if I highlight them like this as I write them down, that helps me remember that helps me make sure that I haven't forgotten anything. So I, put it in white and then I highlight it as I rearrange it. And that makes sure I haven't, skipped one, because then I've got everything highlighted. So once you've done that, then you just need to start combining. So the t to the fourth, if there's no number there, you can always write a 1 in front of there. So I can stick a 1 in front of there. And so that's really a 1 plus 3, which gives us 4 t to the fourth. And then I've got my t squared that doesn't have anything to combine it with. Then I've got a negative 4t plus 2t. So negative 4 plus 2 is negative 2. So that's going to be a negative 2t. And then I have plus 6. And now none of these things can be combined because none of them are like terms. I've got different exponents on pretty much all of these things. So our final answer ends up being 4t to the fourth plus t squared. And if you want, you can write this as a minus 2t instead of a plus negative 2t plus 6. It's the same thing. The plus and negative is the same as subtraction, so you could just leave that off and write it as a minus. Any questions? All right, so we're going to throw in some, other things here. On the top left, we've got 4c squared d cubed plus 3cd minus 10c squared d cubed. And we've got parentheses on just part of it. But because there's no number in front of the parentheses, there's not a minus in front of the parentheses, that is unnecessary. So I can just write this as 4c squared d cubed plus 3cd minus 10c squared d cubed. So when you have multiple variables like this and you're trying to decide, well, what is supposed to go first, add all of the exponents and then, like in one term. So I have a c squared and a d cubed. So if I add the 2 and a 3, that would be considered a 5. So you just find the one that has the biggest number when you add them together, and that's what you start with. So we're going to start with our 4c squared d cubed, and then that also is like terms with this minus 10c squared d cubed. So I'm going to just write that first. You have 4c squared d cubed minus 10c squared d cubed. And then I have this plus cd that doesn't have anything that it matches with, because it's not a like term, it's got different variables. So now I'm going to combine. I've got 4 minus 10, so that gives you a negative 6 c squared d cubed. And then I have plus 3cd. And we can't combine anymore because the exponents don't match. They both have cd, but they don't have the same exponents, so we can't combine those. Now on the right, we have 6.1y plus 3.2x plus 4.8y minus 3.2x. So we have decimals here. Same rules apply though. We don't have any numbers in front of the parentheses. We don't have minus in front of the parentheses, so the parentheses are not needed, and I can just write it in a row. 6.1y plus 3.2x plus 4.8y minus 3.2x. So when you've got two different variables and they both have no exponent on it, we've got an x and a y, we usually put it in order of alphabetical order. So we would put your x's first. So we're going to do the 3.2x and the minus 3.2x. We're going to write those first. So 3.2x minus 3.2x. Then I've got the y. So I'm going to group those together. We've got 6.1y plus 4.8y. So plus 6.1y plus 4.8y. And you always put a plus in between these things, even if you know that 6.1 didn't have a plus in front of it, it's now going to have a plus because it's added on to these other pieces. So when we combine, we have the x parts. 3.2 minus 3.2 is 0. So we would basically have 0x, which is just 0. So that part basically disappears and you don't write it at all. You know, it goes to, it's just not there anymore because it's 0. So all we have is the 6.1 plus 4.8, which I'm going to use my calculator on. And that gives us 10.9. So we get 10.9y. And that's our final answer because the x part disappeared. So sometimes that happens when you simplify. Are there any questions? Okay, so we'll move to the subtraction. So when you have just two things like this, you don't really need to write it as adding a negative. And you notice that I haven't really been doing that when I just have two things and a subtraction. Not really as necessary. So we can just strictly subtract. So we've got 5y z to the fourth minus 14y z to the fourth. So they both have y's. They both have z to the fourth. So you just subtract them. You do 5 minus 14, which I know I'm going to mess that up mentally, so I'm going to do that on my calculator. It gives me negative 9. So we get a negative 9 y z to the fourth. So you're just doing the working with the numbers and the variables hang out. So the same thing on the right. They're both c to the fifth. So you have negative 23 minus 12, and you can literally type that in your calculator. And that gives you negative 35, and then you have c to the fifth. So the subtraction is not much different from the adding, especially when you have just two things here. You just work with the numbers, combining those, and then the variables just get attached to it afterwards. The part where the subtraction does get a little trickier are these problems where you've got them in parentheses. And these are the types of problems where you want to turn the negative into adding, or the subtraction to adding a negative. Because these are the types of problems that people really mess up. So if you need to like bookmark a page, this is the page that you want to bookmark. These are the ones that people tend to mess up. So these problems, if we look at it, we look at the first one on the left. We've got 4x plus 3v minus, and then in parentheses, a negative 3x plus v. So the first set of parentheses we don't need because there's no number or negative in front of it. The second set we do need. So I'm going to rewrite this as 4x plus 3v, and then I'm going to take that subtraction and write it as adding a negative. I'm going to put the number 1 in front of the parentheses. Because when we subtract, what we're really doing is multiplying by negative 1 and then adding the result. So we have to do the distributive property on these types of problems. So we are going to be taking the negative 1 and multiplying it through the parentheses, and then that turns it into an addition problem. So I have 4x plus 3v plus, and then negative 1 times negative 3x is a positive 3x. And then a negative 1 times v is a negative 1v. So essentially what happens when you're subtracting, and you're subtracting a polynomial, is that the signs change inside the polynomial. So instead of a negative 3x, it became a positive 3x. And instead of a plus v, it became a minus v. So the signs are changing when you're subtracting. And then once you've done that, then you have an addition problem. So I'm going to take my x's, because alphabetical order, no, actually v comes before x. So not alphabetical order, I'll do my v's first, but let me color code them. So I'm just highlighting the matching terms. And so you can rewrite this, or actually what I'm going to do now is just do the subtraction or the addition. I've got 3v minus 1v, so that's 2v. And then 4x plus 3x is 7x. And so now that's my final answer, because v and x don't have the same letters, so they're not like terms. And so I didn't write that step where I rearranged it just because I didn't have a lot of space here, because I took up that space with that extra step where I'm doing the distributing. But that's a really important step, and let me star this step. This step is super important because that's the step that a lot of people tend to mess up and they have the wrong sign. And doing this step can help you prevent messing up your signs and getting a negative when it should be positive, and vice versa. There are questions on that example? Okay, so we're going to do the same thing on the right. We have 3h minus 15 minus 8h plus 13. Okay, question. Would 7x equals 2v be incorrect? Yes. So let me just write this here. 7x. Oh, 7x plus 2v. That is also correct. So you could put the x first and then the v. Yeah. You don't want an equal sign because we don't have equal sign here. But if you just rearrange the order, that is still correct, because that's just the commutative property. And the commutative property allows you to rearrange addition. So you can put the x first if you want. And that is still correct. Just no equal signs. That is a very good question. And if it gets marked wrong in Connect Math, especially on a quiz, we will correct for that and give you the points. Because I have seen on a quiz it marks something like that wrong, even though it is the same thing. That's a very good question. Are there other questions on that one? Okay. So moving on to the right, 3h minus 15 minus 8h plus 13. So I don't need the first set of parentheses because there's no number in front of there. But that minus, I'm going to write this as adding a negative, and a -1 is going to be multiplied through the parentheses. And this will make sure that we have the correct signs. So the first parts are going to be the same, 3h minus 15. But then I'm going to distribute -1 times a -8x, or a -1 times 8h, gosh, I'm saying the wrong letters, the wrong signs, -1 times 8h. So that's a -1 times 8, so that's a -8, and then we have an h. Then we have a -1, and we're multiplying by the 13, and that's going to give us a -13. So basically what was in parentheses now has the opposite sign. And that's what subtraction does. Subtraction is basically taking the opposite. And so all the signs basically get the opposite. So now I'm going to find my like terms. So I'm going to just color code them. I've got a 3h and a -8h, and then a -15 and a -13. So that will help me match and do things. So I've got 3h minus 8h. So 3 minus 8 is -5. We get a -5h. And then -15 minus 13, -28. So I'm going to write -28. And don't be afraid to use your calculator. I used my calculator on that one. And if you wanted to, you could put the -28 first, although most people would put the variable first and the number last. So I'm going to move to the one on the bottom left. We've got 3x squared minus, parenthesis, minus x squared minus 12. So I'm going to take that subtraction before the parenthesis. And the general rule is if you have a minus and then a parenthesis, always turn that into a plus and then a -1, because that's really what that does. So I'm going to turn this as plus -1 and then the parenthesis. And then that's a -x squared. That's the same as -1x squared minus 12. So you can add ones as needed if you have like minus signs without numbers. So I have my 3x squared, but I need to do my distributing first. So a -1 times a -1x squared. That's going to give me a positive 1x squared. The negative times the negative is a positive. Then the -1 times the -12. Again, a negative times a negative is a positive, so that becomes a positive 12. So notice that the signs changed. And then when we look at our like terms, the x squared parts match, and we don't have anything that matches with the 12, so that's just going to be by itself. And these are actually already in order for us, which is really nice. So we have 3x squared plus 1x squared. So it's going to be 3 plus 1, which is 4. And then it just stays x squared. And then I have my plus 12. And so then the plus 12 just kind of hangs out at the end. So we have 4x squared plus 12 is the final answer. Any questions on that one? Okay, so last one, because this is my last example. I don't have any more after this. Is we've got in parentheses 6k squared plus 2kp plus p squared minus 3k squared minus 6kp plus 2p. So first set of parentheses is not necessary. So I'm going to just rewrite what I've got here. Second set, we want to turn that into plus a negative and then distribute. I'm kind of running out of room here. Should have put this on a new slide. So first we need to distribute, but I'm going to just rewrite everything on the left before the distributing because that is not changing. And then I've got a -1 times 3k squared. So a -1 times 3 is going to be a -3, and then I've got k squared. Then -1 times a -6kp. So a negative times a negative is a positive. So it's going to be plus 6kp. And then a -1 times 2p squared. So negative times 2, a -1 times 2 is a -2. So that's -2p squared. So we're going to just stick with the order that they have here with, so we're going to combine our k squareds. Those are matching terms. Then we're going to have our kp terms. So I'm going to highlight those. And then we're going to have our p squared terms matching. So I'll start with the gold color here, the k squareds. We got a 6k squared minus 3k squared. 6 minus 3 is 3. Then I'm going to move on to the kp. I've got 2kp plus 6kp. So 2 plus 6 is 8. So I have plus 8kp. And then we've got p squared minus p squared. So that p squared has a 1. So that's really 1 minus 2. So 1 minus 2 is -1. So that gives us a -1p squared. And then that's our final answer because these three things no longer are like terms. Now, sometimes you'll see these things written vertically. So an example would be on this last one, you might see it written like this. And, whoops. This I find a little confusing for some people because they will subtract the first one, do 6 minus 3, but then forget to subtract and they would mess up their signs. Because they would do 2 minus 6 and p plus 2, and they would get the wrong numbers. So I don't recommend doing the vertical method, which is why I didn't do any of these vertical method. If you see it done written this way, I would rewrite it so it's in a row, because you're less likely to make mistakes. Just that vertical method, people make mistakes. They'll get the first one right, but they'll mess up everything after that because they'll forget that it's a subtracting a negative. And so it's just better not even to do it that way, because that way you don't make that mistake. I'm just, trying to give you the way that is least prone to errors. I don't want you to make mistakes if you don't have to. So are there any questions on the last one? Okie dokie. So that's all I've got. That is adding and subtracting polynomials. And we're going to be doing polynomials this week, next week, and the week after. So weeks 4, 5, and 6, we're dealing with these things. And then weeks 7 and 8, we'll switch to something different. So, if you get stuck in weeks 5 or 6 on something, you can always refer back to this week for some of the basics, because this is really where you're learning the basics, and then we're going to go from there. So if you have questions on other stuff in the class, you know, you can email me, and I'm happy to help. You know, this stuff this week kind of gets a little bit harder for people because it's like, oh man, now we're doing multiple variables and exponents and stuff like that. But it's very doable. So, and you'll get better as you have 3 weeks to basically practice this stuff. So you'll definitely be able to do it. So, all right. Well, I will let you go to, you know, whatever you're going to do for the rest of your evening, and I will talk to you later. So thank you for attending. Bye.